Hey everyone, and welcome to this explainer from the Foundry by Forge College. Today, we are diving deep into the hidden technical interfaces that literally turned Web 2 into a massive interconnected giant. You can think of the modern internet a lot like a sprawling city. We always see those flashy storefronts, right? But today, we're going underground. We're going to look at the plumbing, the blueprints, and those incredibly strict security doors that keep the whole shebang running. And more importantly, the massive power dynamics they carry.
So, if you remember back in our previous lesson, centralization, data control, and security trade-offs, we talked about how platforms hoard our data in these giant, centralized databases. They control it, they monetize it, and they guard it with their lives. But, well, here's the paradox. To actually be useful and to grow those massive ecosystems we use every day, these platforms have to share that data with outside apps. So how do they actually pull that off without just handing over the keys to the castle? To really get this, I want you to imagine that centralized platform's database as a highly exclusive, heavily guarded data club.
Okay, let's dive into this. Here is the blueprint for today's exclusive nightclub tour. We're going to start at the data club, uncover what APIs actually are, look at how you show your ID, break down a really useful three-part mental model, expose some of the big privacy risks, and finally, prepare ourselves for Web 3.
All right, section 1, welcome to the data club.
Picture this. You're walking up to the absolute hottest nightclub in town. Now, inside is all the incredibly valuable user data. We're talking profiles, friend lists, payment histories, the works. The owners definitely want promoters to bring in business, but they obviously can't just let anyone wander into the back office and start looking around. Enter the API. It is essentially the strict bouncer standing at the front door. You make a request, say you want to post a photo, and this bouncer checks your credentials, consults the club rules, and then either lets you through or tosses you out. It is the ultimate gatekeeper. Moving on to section 2. What are APIs anyway? So, stepping away from the nightclub analogy for just a second, what is this bouncer on a technical level? Well, API stands for Application Programming Interface. It's basically a formal set of rules that lets entirely separate software components talk to each other. And a web service? That's just an API that's exposed over the web. Now, here is the absolute superpower of this setup. APIs completely decouple the messy internal plumbing from the outside world. Think about it. A major platform can completely rebuild its entire database overnight, and external developers won't even notice, just as long as the API stays exactly the same. It's brilliant. Now, what's really interesting here is that these digital bouncers can actually speak a few different architectural languages, depending on the club they work for. REST is the one you'll see the most. It's simple, reliable, and great for public web APIs. Then you have GraphQL, which is fascinating. It's kind of like handing the bouncer a hyper-specific grocery list, so you can get exactly what you want in one single trip. gRPC is built for pure, high-performance speed, using binary framing. And SOAP? Well, that's the strict, slightly older language you usually run into when dealing with the legacy enterprise systems. They're all different tools, but they all exist to mediate access.
Section 3, showing your ID, authentication.
But here's the thing. Just speaking the right language isn't enough to get inside. When you walk up to that bouncer, you can't just say, "Hey, trust me." So the crucial point we need to clear up is the difference between authentication and authorization. People mix these up all the time. Authentication is the bouncer checking your ID to answer, "Who are you?" Authorization, on the other hand, is him checking the clipboard to answer, "What are you actually allowed to do? Are you general admission or are you on the VIP list?" You absolutely have to have both. And engineers have come up with some pretty brilliant patterns for handling this. Session cookies keep your browser logged in. API keys are essentially like long-lived passwords specifically for servers talking to each other. OAuth 2.0 is incredible. It's honestly like giving a valet a special key that only starts the car but physically won't let them open the glove box, which keeps your actual password hidden. And JSON Web Tokens, or JWTs, are basically cryptographically signed VIP passes. By the way, if you love the nuts and bolts mechanics of this stuff, we actually have hands-on programming labs for building these exact patterns over at Forge College. Section 4, Gateway, Contract, and Cache. To really master how these interfaces work, we need a mental model to visualize the engineering trade-offs being made. And this brilliantly illustrates the concept by breaking an API into 3 distinct layers. First, you have the gateway. This is the choke point controlling access and stopping spam, will be called rate limiting. Second is the contract, which is just strict rules about exactly what the data will look like when you get it. And third is the cache. This is a memory layer that saves recent answers to prevent the whole system from crashing under heavy load. The key takeaway?
You are constantly trading perfect up to the second accuracy for massive global scale.
Section 5. The privacy and security risks.
So what happens when centralized gatekeepers end up holding way too much power over these interfaces? Well, this quote really hits the nail on the head. Because the platform owns that gateway we just talked about, the API isn't just a piece of code anymore. It is a commercial weapon. Terms of service and rate limits, those are actually governance tools. A major platform can maintain a monopoly simply by turning off the API tap for a rising competitor. At the end of the day, the technical choke point is the business power.
But it's not just intentional corporate power plays we have to worry about. There are massive privacy risks baked right into the engineering itself. Remember that cache layer? Well, say you unfriend someone, but the API serves up cache data to save processing power. That deleted profile might still be totally visible to third-party apps for several minutes. Or, what if a lazy developer asks for a super broad OAuth scope just to run some basic analytics? They might accidentally gain full access to your private direct messages. Literally, small implementation choices can create massive unintended data leaks.
And finally, Section 6, Preparing for Web 3.
So the Web 2 Data Club gave us this unbelievable global scale, right? But the trade-off was that it centralized all the control directly into the hands of a few giant gatekeepers. If we want to evolve past this, we can't just change where the data gets stored. We actually have to change the interfaces themselves. We must lower those single points of control at the gateway, the contract, and the cache. We basically have to figure out a way to keep the thriving ecosystem, but get rid of the omnipotent bouncer. And that brings us to the ultimate question, doesn't it? So how do we actually fix this single point of control? How do we build a web where applications can talk to each other seamlessly without having to rely on a centralized gatekeeper who can just shut you off or leak your data on a whim? Keep that provocative thought in mind for our upcoming lesson. Thank you so much for joining me for this explainer. To dive deeper into this and everything Web3, be sure to visit forge.college. See you there.